Okay, so we're going to pick up where we left off last time with talking about JDBC, Java Database Connectivity API. Remember that we had a kind of a summary of what we've looked at so far with respect to databases. But now our goal is to programmatically connect to a database and process data, meaning that we're going to write a program. And every language supports some sort of API for connecting to a database because it's so fundamental. If you're JDBC is what is used in Java at a lower level. If you were like in C or C++, you would use ODBC, which is Open Database Connectivity API. If you were in Python, you'd use something else. I generally use Pickle or something for instead of an actual full database. But the whole point is that you do not write code to connect to a particular database. You don't write code to connect to a MySQL database or a Postgres database. Just a second, let me check this. Yep. All right, remember we are online, so if you have any questions, post to the YouTube live stream. But we don't write code to connect to a Postgres database or an IBM database or a SQL server or something like that. We write code to connect to an API, an application programmer interface. This is a perfect illustration of that dependency inversion principle from the solid principles. You do not write code that depends on low-level modules or components. You write code that depends on an API. And then somebody else comes in and provides code that implements that API so that you can keep those completely separate. We had a bit of a connectivity issue on Monday, but I went ahead and grabbed an older SQL file here, MySQL connector J, and I added it to my project here. So we're going to go ahead and connect to the database, and we're going to pull person data. Just to remind ourselves of what this looks like. We've got a person table, we've got an email table because it's a one-to-many relationship. We've got that account table, and then we've got that ownership table. I want to focus on these first two over here and pull some data just to see it and get it working. All right? So first of all, a little bit of an overview. We've already talked about a little bit of this stuff already. But again, our goal is to programmatically connect to a database and process data because that's really what you're creating this program for. Over here, if I were to process everything in MySQL Workbench, that's where it stays, right? If I can go ahead and find all the people in this database. Oops, let's go ahead and use my database first. There we go. And then execute this. I can find all 5 of these people that are sitting in the database, but that data stays in MySQL Workbench. If I'm going to be doing manual stuff, like interactively, me, a person, then great, fine, go ahead and do that. That's what MySQL Workbench is for. But you're presumably writing this program to process data on a front end and process data on the back end and save data and load data. So what you're going to want to do is you're going to want to write code to do it, okay? And that's where JDBC comes in. Again, most languages have support for it. JDBC stands for Java Database Connectivity API, and then we always have yet another acronym. API stands for Application Programmer Interface. And again, it's a perfect illustration or use of dependency inversion. Right? You do not write code that connects to MySQL, right? You write code that interacts with an API, right? And the API in this case, JDBC, provides, and it provides a lot of stuff, but we're going to focus on 3 things. It provides a class that represents a connection, right? Just a generic connection, not a MySQL connection, not a SQL Server connection, just a connection, right? And then you have what's called a prepared statement. There are other statements, there are unprepared statements, but we're not going to use them because it's terrible practice. You leave yourself open to what's called an SQL injection attack that we'll talk about later. And then finally, you're going to be getting stuff back from the database. So there's a notion of a result set. When you make a query to a database over here in MySQL Workbench, for example, I get these 5 things back, right? And each one of these has 4 columns. So what I'm going to do is I'm going to get a result set, a way to represent these 5 results here in Java so that I can iterate over them and process them. Right? Those are the 3 things that it provides. Vendors, as in people who create databases and want to sell their databases, like Oracle, IBM, etc., They provide a driver library that conforms to that API. And that's what we did when we brought in this jar file. That's the driver file that is published by Oracle for MySQL databases. If I were to switch this over to Informix or switch this over to SQL Server, I would not have to change a single line of my code. All I would have to do is take this jar file and throw it away and put in a new one, right? Because of dependency inversion. We've taken out the dependency on that low-level database, and instead we are writing it towards this API right here, right? And then all we have to do is bring in a jar file that implements that API, okay? Also, as we're not going to go over it, but you should be aware that there's a more advanced topic called ORMs, which are object relational mappings. They're systems like JPA or Juke or something like that, where you can actually annotate your classes, very similar to some of you used, no, most of you didn't use annotations, but some, like a library, you can bring in a library to do a lot of the heavy lifting for you. You can bring in a library like JPA and then annotate your classes and say that this class is connected to that table in the database, and that variable in that class is connected to that column in the database. We might be, if we have time, we might go over this towards the end of the semester, but then it takes care of all the loading and persisting for you, right? But the problem is that you have to have a really, really clean mapping between your POJOs, plain old Java objects, and your tables in your database, all right? All right, so let's come over here and connect to the database and just let's pull those 5 people that we know that are in the database right now, right? Grace, Alan, Margaret, and Donald, and Joe, right? Joe Unix there, right? All right, so how did I connect to that database over there to begin with in MySQL Workbench? Right? I provided a URL, a username, and a password, right? And once you save those, you never had to enter them again. We need to do the same thing over here. I need a string URL. I need to connect to the CSE server.unl.edu question mark, right? We're going to come back to that. I need a username, right? Which is going to be me for today, right? And then I need a password. Right? Remember when we told you do not use a password that you care about? Come on. This is why. At least for the purposes of this project, you are going to be storing your password plain text in Java code. If it's a password that you care about, you're exposing that to your partner and or to me and all the other LAs and graders. So make sure that you're not using a password that you care about. Right? Okay, so I've got my username and my password here. It's actually a little bit more complex, right? You're not going to be, it's not like HTTPS, right? cse.unl.edu. That would be a web address. HTTPS is the protocol. You're connecting it to it using hypertext protocol secure socket layer, right? We're not going to be doing that. We're going to be connecting to it using JDBC as a protocol and MySQL specifically as a protocol. So don't worry about it. In fact, it's much more complicated than even this. So I'm going to go ahead and jump over to my notes here and cut and paste what you actually need. Right? There you go. Did you get that? Yeah, all right, so you've memorized it, and so you can write it down later. Don't worry about it. It'll be in your lab. It'll also be in the notes when we go ahead and post this stuff. All you need to do is basically change what you're connecting to. Everybody here is going to be connecting to cse.unl.edu. You're going to be connecting to your database, not my database, right? So you need to change that. There's a whole bunch of other stuff that needs to be set up because of the configuration of the server, but most of this stuff will get it to work. For example, you have to set the time zone to UTC, Universal Coordinated Time. In other words, Greenwich Mean Time. Okay. Once we've got those 3 things, we need to make a connection. So there's a connection class in the MySQL SQL library in Java, and I'll just call it con. Right. Now let me go ahead and bring this in. Oops, there we go. Come on, import that. And where was it located? It's located in java.sql. Who would have thought, right? Java.the SQL library and then the connection, right? Now to actually create this connection, there is something called a driver manager. Remember, what is a driver? A driver is an implementation of this API. In other words, this jar file over here. So a driver manager is responsible for scanning that jar file and finding the driver necessary to make the connection. We're going to let it do its job, right? Dot get connection, right? And we're going to provide it the URL, the username, and the password. There we go. Okay. Now, it is complaining about this because, unfortunately, JDBC is kind of old. All right, well, it's stable. We don't want to call it old, as opposed to new and shiny, cool, and unstable. It is old in a good way. It is stable, right? However, it goes back to, I think, Java 2 or so. Back when they thought that checked exceptions were a really cool thing to use. Remember, no other programming language, to my knowledge, has decided to adopt that feature, right? And in fact, for the most part, Java has given up on it. Remember that a checked exception is one that you have to try and surround with a catch statement here, right? So you're forced to surround this with a try statement, catch any SQL exception that it could occur, and then deal with it. Right? How do you deal with a server being down? How do you deal with a bad password? Right? How do you deal with somebody deleted your database and there's nothing you can do now, right? Oops, I accidentally deleted the database and I'm trying to connect to it now in a completely different system. There's not really anything that you can do to recover. So how did we deal with this? We were anglers, remember? We caught a fish. Oh, great, this is an awesome fish. We weigh it, and what do? We throw it back. A new runtime exception. Right? Exception. Only if you're going to eat the fish do you keep it. Right? There we go. All right. So we're going to rethrow this exception because there's really no reasonable way that you can recover from this, which exemplifies why checked exceptions are a bad design. Because if you look at the original Java specs, it says when should you use a checked exception, and the guidelines are if you can reasonably recover from the exception, then you should use a checked exception. How do you reasonably recover from no internet, the server being down, bad password, et cetera, et cetera? There's no way, right? So this exemplifies why checked exceptions were a bad idea 25 years ago. Right? In any case, we've got our connection. Let me go ahead and run it and show you that it works. Right? I'm not doing anything, so it works. Great. Right? If it doesn't work, this is Computer Science 3 now. Right? There's my the wrong password. Right? It's going to run, and it's going to say access denied, just like if you put in the bad password in MySQL Workbench. Access denied for using that, or if you try to go to I'm root now, all right? And I have no idea what the password is, but if I tried to do something like that, of course I'm going to get server is running in secure auth mode, but root has a password of an old format. Wow, please change the password to the new format. Somebody could probably check and see if it's like a guest password or something like that and see if they can get into the system right now. In any case, don't do that, right? I'll do that later because that'll be fun, right? Find out what password they've been using for the SQL server. Anyway, if everything goes right, then you shouldn't get any exception here at all, okay? All right, well, there is a problem here though. If you were to open up a file, right, process that file, just like we're opening up a connection and processing data from that connection, what's the last step you should do? If you're opening up a file, processing the file, and then what? Close the file. So we should do that as well. Con.close. Right? Once again, it's going to complain about this because everything in SQL throws an SQL exception. Right? So once again, I'm just going to say, okay, I don't know how to deal with that. Let's go ahead and throw it. If you did not have this, guess what? You are really, you're throwing the dice and crossing your fingers here that the server will actually reset your connection for you. You open up one connection, two connections, three connections, ... You open up 30 persistent connections, and you try to open up that 31st one without closing the first 30, it's going to throw an exception at you. Why? Because the server only allows you up to 30 connections. I've actually got two connections open right now, the one that I just opened, but also the one that MySQL Workbench is using, right? So once you hit 30, that's it. Any more, and you're done. So if you do not close your connections, you might be running out of them really, really quickly. And then cross your fingers and hope that they all get reset. cross your fingers that, or wait 5 minutes, because I think after 5 minutes it times out and it gets reset anyway. Sometimes it gets confused, and you might have to actually put in a ticket to say, please reset all my connections. Very, very rarely, but make sure that you're closing your connections and you won't have that issue, right? Okay, as you can see here, I've got 2 try catch blocks. As an alternative, what you could do is you could surround all of this with to do the rest of the program, ... all right? And then close it at the end here. That relieves you of the need to do it down here. Right? Your choice. Again, checked exceptions were a design flaw in my view. So if you want to do it in one big giant block like this, if you want to be more intentional and have multiple blocks like this, that's up to you. Okay? I'll go ahead and do everything up here in this one block up here. Right? And leave this as a reminder that you can do it in multiple blocks. Okay? Okay. We've got our connection. It still works, right? Save, yes. Yep, it still works. And we're successfully closing the connection now. Great. If you really want to be paranoid, you can go ahead and put it into a finally block. I don't know if we talked about this, but finally blocks are executed unconditionally. So con.close, whether or not there is an exception thrown somewhere up here, or no exception at all, it'll actually close down here. The problem is, if you do that, then what do you have to do? You have to surround it with another try catch, right? Okay, add surround try catch. There we go. And then I actually want to put this into a finally block because I want to make sure that it does it. Okay, so
let's do it again.
Do it again. What happens? Infinite recursion here, right? So this is the one instance at which I would say don't bother doing it in a finally, right? Because you're just going to hit another checked exception. And yet another illustration why checked exceptions are terrible, right? I'll do it up here. Good. All right. So to do the rest of the program. There is a step-by-step process, right? I'll describe the process right here. So process. So one, you create a connection, right? We just did that. You need your username, you need your password, and your URL. Then you create or prepare your statement. You prepare the query, you execute the query, and if you're expecting results back, you process your results. And one thing that I should put here and at the end is close your resources, right? Failure to do so will eventually mean that you run out of resources and you'll be stuck for the next 5 minutes, okay? All right, so what we're going to do next is we're going to create or prepare a query. All I want to do is pull these people records right here. Right? I did that by executing this query right here. So here's a troubleshooting tip. Generally what I do is I write my queries in MySQL Workbench. Once I'm sure that they work, I copy them, I bring them over here, and I put them into a string. Query is equal to, oops, and I don't want all that. There. There's my query that I'm going to execute. 2 things to note here. First of all, over here I'm using lowercase conventions, right? Remember that it's case insensitive generally, right? And so really old school folks will go with select from. Why? Well, because if you were back in 1970 and you only have one color of screen, green, right? A green screen, then you want to offset your keywords in SQL by making them all caps. We don't live in 1970 anymore. What color is that? Blue, right? It's highlighting this stuff, right? We've got more than one color now. So over here, what I like to do is but this might be an argument for going back to the old school way. Why? Because do you have color coding within the string right now? No. So if it's your preference to go ahead and go with old school ways of doing things, go ahead and do it. I still don't like that, right? Because then I'm holding my finger down on the shift key the entire time that I'm typing, and that's a good way to get early arthritis, right? So don't do it. That's my suggestion, right? Another thing here is that you've got this semicolon. That becomes optional over here in JDBC because it will automatically be put in there for you. I like to get rid of it simply because I don't like confusing those 2 things. There's 2 semicolons now, right? Get rid of it. We will talk about the usage of this wildcard here. Generally, you should not do that. But we're going to do it initially here just to get it up and working. Okay? There's our query. All right, once we've got our query, we need to prepare that query, and I'll show you why you need to do that later on. But for now, we're going to go ahead and create a prepared statement, PS. And the connection is what's going to prepare that statement for us based on that query. Again, that's going to be in the java.sql library here. Driver manager, connection, SQL exception, prepared statement, it's all in the same library. It's all in the same package over here, java.sql. Once I've prepared my statement, I can now execute that statement and get back a result set. Just like if I executed it over here, then I would get back those 5 people, Grace, Alan, Margaret, Donald, and Joe. Okay, so that's going to be in a result set. RS is equal to ps.execute query. There we go. All right, that's going to return a result set, and I just need to import this. A note on variable names here. Query, PS, RS. Not ideal variable names, but what else are you going to call them? The person result set, maybe, right? But then you're still putting result set into it, right? It's not people yet because it's not a list of persons, which is what we're going to make here in a second. It is perfectly fine to do this. Unfortunately, if you start doing multiple ones, you'll have prepared statement 1, prepared statement 2, prepared statement 3. Rethink what you're doing because that does get kind of smelly, right? Remember code smells? Code smells are something that kind of may not be something that's absolutely wrong. It might run, no bugs, it's okay, but it still kind of stinks, right? It might just be a little bit past its expiration date, right? That's what we call code smells, okay? But otherwise, I've got my result set here, right? Now what I need to do is process the result set. The way that you do this is by going into a loop. So would you suggest a for loop for each row in the result set? Right? Dot, dot, dot. Oops. Code completion there. Well, first of all, do I have a for each? Nope. Not even Python has for each. It's got like a dot for each maybe method. Okay, we do have enhanced for loops for something something, but enhanced for loops were actually introduced later in Java, and JDBC actually predates it. So we've got to go really old school here, right? Do you need? So do you know? Would a for loop be ideal here? Do you know how many results you're going to get back right now? Nope. So let's go ahead and go with a while loop here instead, right? And here's the form that we're going to take. See this little arrow right here? That's what's called a cursor. We're pointing to the first record here. Before it even gets started, though, we're not pointing to any record. So the pointer is actually pointing before the first record. Then what I'm going to do is I'm going to say, give me the next record. To do that, I go with rs.next. What that's going to do is that's going to take that pointer and point to the first record. So now it's pointing to the first record. Process each one of those columns. Now what you need to do is you need to go to the next record, right? 20 in this case. Next record, next record, next record. How do you know that you're done? When you're past all the records in the result set, this is going to return false. So I'm going to go ahead and just put this in as a while loop. Right? While RS, kind of like the scanner has next, except it's not called has next. It should have been called that, but that's 25 years of hindsight. While the result has next, go ahead and give me the next. It does it in one line, right? So we're going to advance the pointer to the next record, and it'll return true. Yes, I'm pointing to a current record right now. Advance it to the next, here's 4 records, say, 5. Advance it to the next record. The next record, true, 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 true. What happens when you advance past that last record? False. That's what breaks me out of this while loop. Yeah?
That in mind. Oh, wait, no. How do we get the index of what we're at right now?
There is no indexing because it's a set. Right? There is no first, there's no, because SQL is unordered. right? Unless you put in an order by, right? Order by clause, then you're just going to get back a bunch of records, right? And by its very nature, it's still going to be a set. So I'm going to process the current record within this loop. To do that, I'm simply going to ask, give me that column, give me that column, give me that column. What are the columns named? Person ID, first name, last name, date of birth. The first one is an integer. All the others are strings. So let's go ahead and get those 4 columns from the current record. I need an integer to represent a person ID, right? Is equal to rs dot get int of the person ID. Right? Oops, there we go. So I'm going to get this as an integer. Which column do you want? Person ID. You don't have to go in any particular order because it's unordered, right? I'll go ahead and go in order because it makes sense, right? String first name is equal to rs dot. Now this is not an integer, it is a string, so get string. And what do you want? Well, I want the first name. Right? How did I remember that the column was named the first name? Because I'm using a consistent naming convention that exactly matches the conventions that I'm using in Java, right? String last name is equal to rs.getString and last name. Right? No guesswork here at all. String date of birth, and I'm going to call this something else, str, because it's a string representation. rs.getString of date of birth. Do you really want to represent a date of birth in Java? Do you really want to represent a date as a string? How are you going to compute the number of days from the beginning of a lease to the end of a lease? I'm not going to do it. Yeah.
If it returns it as a string, couldn't you do parse local date within get return?
That's exactly what I'm going to do. I'm going to do it in a separate line here, though, right? So local date, date of birth, is equal to local date dot parse date of birth string, and be done with it. As you point out, you could go ahead and take this and get it down to 1 line instead, right? Go ahead and give me the date of birth, and then put it into parse, and then go ahead and parse that out as a local date, right? All right, what do I do with those 4 things now? I could say print them out, right, to make sure that everything is correct, but why are you loading this data up to begin with? Because you want to represent a what? A person as a plain old Java object. So once we've got that data, let's not just print them out. Let's go ahead and create a person. P is equal to new person of the first name, last name, and date of birth. There we go. And I need to import this because it's in another library. And what's wrong with my constructor? Oh, I don't have a date of birth here. All right, fine. I'll go ahead and add it. Actually, should I go ahead and type? Or make a constructor, what is it, source, generate constructor using fields. I want everything except for emails. Great, good to go, done. Now my other code is actually going to compile as well, right? Except that dry, should you repeat yourself? Nope. I'm going to go ahead and call this on first name, last name, and then null for a date of birth, because I don't know what it is. Right? I'm going to move that down here. Right? That's the most general constructor that I have so far. Right? And so I'm going to have this constructor call that constructor by just passing along the first name and last name. Right? Don't repeat yourself. If you've got multiple constructors, make sure that only one of them does all the heavy lifting and all the others foist all the work onto it. Right? There, I've got my person. Okay. What am I going to do with it? Now I could print it out, print out the person, ... I'm loading up all the people, right? So I probably want to put it into some sort of a collection. Let's come back up here and create a list of persons, right? People, everyone, right? Is equal to new array list of persons. Bring this in, import, come on, import. There we go. Everyone, think of a better variable name. People, right? Persons dot add p. There we go. Now at the end, let's go ahead and print them. Now let's print them all out to make sure that it works, right? So for person P in the collection everyone, I will go ahead and say system.out.println. Hopefully I did a toString method so that I don't have to worry about pulling out each individual thing and then printing it out. Again, that's something that we're seeing with assignment 3, where you take a bunch of logic to print something out, like say an invoice report, and then you're putting it somewhere completely different other than the invoice class. Sounds like an invoice thing to me. Where should it belong? In the invoice class. In particular, probably the toString method, so that you can have really, really simple code that looks just like this. Just print it out, print it out, print it out. Let the class handle its printing. Right? There we go. There's Hopper, Turing, Hamilton, Knuth, and Unix, Joe Unix. How do I know that I pulled the rest of it out? Well, if you need to, go ahead and modify your toString here, right? Or your toString method, so that you're printing everything out that you care about. One piece of data that I pulled out of the database that is not being modeled here is what? That person ID. Why? Because it has a connection to the database now. Maybe that's an argument for coming back here and changing my design. Private int person ID. Right? So, to do, consider this. Why would you want to do that? Because you might need it. For example, if you want all that person's emails, if you want all of Alan Turing's emails, what are you going to have to do? Go over to the email table. What information do you need about Alan in order to get all of his emails? That foreign key right there. Right? So, to do, consider this. I've considered it. What am I going to do? Do it. Right? And then I'm going to modify this int person ID. There we go. And this dot person ID. I won't bother with generating the code. It's just that simple. There we go. And now over here, it's going to, this would be, I don't know, 0, right? Some flag value. Maybe that's an argument for making it a big I integer, because there are some things that you can create an object without a connection to the database, right? Maybe it's null instead. So over here, I will go ahead and make sure that I'm also giving it the person ID. There we go. Okay. You know what? This seems so useful. Like, am I only going to want to pull a list of persons just for this main? Probably not. So what should I be doing with this code? Probably put it in a class or a function. Okay. So let me go ahead and create a new class. I'll call it database loader. Right? I could put this into a public static list of person, load persons, right, from the database, right? By the way, should I put that in the name, from the database? Right? Probably not. Why? What's the name of this class? Database loader, right? So why should I repeat myself? Right? It's load persons in the database loader class. It's obviously loading it from the database. Okay? There's everyone. I make sure to close all my resources and return everyone. There we go. Oh, by the way, I didn't close all my resources. I opened up a connection. I then opened up a prepared statement. I also opened up a result set. Each one of these things should be closed. Should you close them in the following order, though? rs, or I don't know, ps.close, and then rs.close. As we'll see here in a moment, order matters. If you close the connection, that severs the connection to the prepared statement and the result set. The result set was created by the prepared statement. The prepared statement was created by the connection. So if you want to close these things, you need to close them just like over here in the, when we created a table, we had to drop them. We have to delete the tables in the reverse order. You should do the same thing with your resources. So what was the first thing that we did was the connection close. So that's the last thing we should do. What was the second thing we did? Was the prepared statement. So that's the second to last thing we should do. Right? There we go. Should I close the result set right there. While you're iterating over it, after the first one, close it. What about those other 4? Nope, I need it, so don't do that. All right, let's come back over here to the demo, and I can get rid of pretty much all of this, except the database loader dot load persons. There we go. Oh, was I printing it out still over here? No, I was not. I'll do it over here. So I'll just do it in one big giant thing, everyone. There we go. There, I've still got Hopper, Grace, comma, Turing, Allen, comma, comma, comma. So it's not very well formatted, but at least I know that it's still working. Okay? You know, this sounds familiar. What have we been doing up to this point before databases? We've been loading stuff from where? Flat files, right? In other words, most of you, either after the first phase or hopefully, certainly by the second phase, have some sort of a class called, I don't know, file data loader? Yeah. Data loader? You might have just called it data loader or load data or something like that. Right? Should probably be nouns though. And you had something that looked very, very much like this. And I'm not going to do it for you because you've done it, right? But you had some sort of a return. I'm going to just return null so that it actually, compiles. Ooh, what's the difference between those two methods? The class, right? It's they're both static though, same exact name. Maybe there's a way that we can leverage object-oriented programming now to refactor this and think more object-oriented, right? What if I had, say, an interface, a generic data loader interface, right? That defined a public list of person, load persons. There we go. And I have to bring all this stuff in because I'm not in the, oh, come on. Okay, list first, I guess. I'll bring that in, and then I can bring in the person. There we go. All right. Now, what if each one of those classes that I just created, the original class that you probably have right now, and then my new class, what if I implemented those interfaces? What if I implement data loader? Right? Take away the static, right? And now I'm implementing that interface. Over here, take away that static, implements data loader. Right? And now I'm doing my own dependency inversion. Because over here in the demo class, do I need a database loader anymore? Nope. All I need is a generic data loader, right? DL. DL. Right? Now, is it a file data loader that's loading up from a bunch of CSV files? Or is it a database data loader that's loading up from a database? Or is it now I should have called this, instead of file data loader, I should have called it probably CSV, because that's what you're doing. But what else could you do? You could load stuff up from an XML file. You could load stuff up from a JSON file, right? You could load stuff up from something else, whatever data interchange formats are out there, right? What would you have to change over here in this actual code? Suppose that there was 1,000 lines of code after this that actually processed that data. Would you have to change any of them? Nope. All you have to do is change, am I going to be using a database data loader or a file data loader, right? In either case, right, you don't need to change any code after that one line, after you've instantiated that one thing. All right, because I'm thinking object-oriented now, right? There is a common interface, a generic common interface, dependency inversion. I write my code after this that goes to that interface right there. There's a load persons, there's a load whatever, load, right? Implement all of those, and all you have to do is change one line of code where you're loading from. So database, data loader. Did I call it database loader? Sorry, there we go. All right. Let's go ahead and run it. And it still works. But it's much better from a design point of view because I'm not depending on a database. I'm not depending on necessarily a file, CSV, JSON, or XML, or whatever. I am depending on an interface, a generic interface. Right? We did not expect this from your second or third, or the second phase. We're not expecting it going forward, but start thinking in those terms. Make it easier on yourself, right, by doing stuff like this. Okay? All right, what else? Oh yeah, so let's go ahead and let me go ahead and modify the person class instead. All right, I'm going to go ahead and add their ID right here, %d, this.id, right? And then I'm also going to add a bunch of emails, %s. This.emails oh, here, I'll just go like this. Hopefully I can do this. There we go. Let's run this. Oops. Oh, I'm not actually printing them. So for person P in the collection everyone, I will say system.out.println P. Right? I want to print everybody, right, in detail. So there's Grace Hopper, Alan Turing, Margaret Hamilton, Donald Knuth, and Joe Unix. You know, same. Load emails here, ...